Okay, hi again. Welcome to part 4 of CCNA IP addressing. Last time I gave you the concept of subnet masking, and if you remember, wherever there was a 1 in the mask, that meant to the router or PC or whoever that this was part of the network portion of the address, and wherever there was a 0 in the mask, that meant this was the host portion of the address. So what we could do is put a longer mask. Here's the same address as we had last time. Remember, the address was 172.16.2.17, and what we've done is to apply a longer mask to it. So now the mask reads 255.255.255.0. That means all ones in the 8-bit position, first octet, all ones in the second octet, all ones in the third octet, and zeros in the last octet. And the router or PC or whatever looks at that mask and says, okay, I get this. It's 24 bits of networking space and only 8 bits of host. So by using this subnet mask, we can now tell the boxes exactly where we want them to draw the network host portion of the address. They know how much is network and how much is host. Okay, great. It's all very well saying computers say, oh yes, I get this, any 1s in the bit position are network and any 0s in the bit position are host. But actually they don't do that. They're just machines, they're computers, they're adding machines essentially. So what they actually do is a logical process known as a logical AND between the two addresses. And a logical AND is a very simple sort of basic form of computer understanding, if you like. Essentially, here's a truth table which describes the way that a logical AND works. If we get 2 zeros and we add them together, AND them together I should say, if we AND 2 zeros together, the result is a 0. If we AND a 0 and a 1 together, the result is still 0. If we AND a 1 and a 0 together, the result is still 0. The only time we get a 1 as a result is when we AND 2 1s together. And that's what the computer's doing between the IP address that we've configured on it and the subnet mask. So let's just see that happen. Here's an IP address, 172.16.2.17, our old friend again. And what we've done is convert the whole address into binary. And then we've got our mask that we're going to apply to that. In this case, 255.255.0.0. 16 1s followed by 16 zeros. And then we're going to do the logical AND between them. Let's just do a couple of octets here. So first octet, 1 and 1 is 1. 0 and 1 is 0. 1 and 0, sorry, 1 and 1 is 1. 0 and 1 is 0. 1 and 1 is 1. 1 and 1 is 1. 0 and 1 is 0. 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 1 and 1 is 1. 0 and 1 is 0. 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 So that's all the router is doing. It's taking the address and it's doing a logical AND between the address and the mask, and whatever the result is the network portion of the address, which we're now going to call the subnet. So the subnet portion of the address, or the network portion of the address, is a logical AND between the IP address and the subnet mask. And it doesn't matter where we move this line, it doesn't matter how many 1s or 0s we have in the mask. So here's the same address again, 172.16.2.17. Got a different length mask on it this time. Got 255.255.255.0. Computer does the logical AND between the two. Whatever the result is the network portion of the address. So in this case, we do the logical AND again. I'm not going to go all the way through it again. But if we go through it again, you find the subnet drops out when we convert it back into decimal as 172.16.2.0. And as I said, the computers don't care about these 8-bit octets. They're not interested in blocks of 8. It's only us that are interested in blocks of 8 so that we can talk about the IP addresses. So it doesn't care where you draw the mask. So here's again the same network address, the same IP address, 172.16.2.17. We're going to do a logical AND between that and a longer mask still. So this time we've got 28 bits of networking and only 4 bits of host. And if we convert that into decimal, the mask looks like this. It says 255, all 1s in the first 8 bits, 255, all 1s in the second 8 bits, 255, all 1s in the third 8 bits, but only the first 4 bits of the last octet are set for 1, with the last 4 bits being set to 0. And if we convert that into decimal, we get the last portion of the mask being 240. So it's 255, 255, 255, 240. Computer doesn't care, it does a logical AND between the IP address and the subnet mask, and the result is the subnet portion of the address, the network portion of the address. Now, it looks to us as though that might be a host address, but it's not. It's a network address. So the network is 172.16.2.16. Okay, if we know that, then we can have a look at this little subnet mask exercise where we've got an address and a subnet mask. So look at the first address. The address is 172.16.5.33 with the mask of 255.255.0. So just by looking at the mask, it's easy. We can say, okay, the first octet is network, the second octet is network, the third octet is network. So we can work out what the subnet is. First of all, what class address is it? Well, it's in the range 128 to 191, therefore it's a class B address. And the subnet, or network portion of the address, is the first three octets, 172.16.5.0. Have a look at the second address here. We've got 10.9.15.3. We've got a mask of 255.255.0.0. First of all, first thing we can say is that because it starts with a 10, this is a class A address. And the subnet portion of the address, or the network portion of the address as far as the router is concerned, is 10.9, the first two octets, .0.0. Remember, you always have to talk about the entire address, even if you haven't got the host portion set. Last one, the third one, 198.17.23.24 with a mask of 255.255.255.0. So it's a class C address because it's in the range 192 to 223. And also, we can tell what the subnet portion of the address is. It's 198.17.23.0, because the mask is 255.255.255.0. Okay, that's end of part 4. Thanks for listening again. We'll do one more part, part 5. If there's more interest, I might do some more. You never know.